Hey, grade nines. So, welcome to lesson 6.2. Now, what we're going to be doing is, well, still solving. We're going to be solving for x, but we're going to just introduce one more step to start, right? So, what I mean by that is, let's say we had an example like this one. Whoop, one sec. Like this one. Okay, well, if we were going to do what we were doing in the last lesson, then we would need to get x on its own, and then get all the numbers to the other side. But you probably immediately kind of see that we have an issue here, right? We have two x's. Which one do I get on its own, right? So this is where we're going to do something called collecting like terms. And this should sound familiar because we did this in the last unit, right? When we were doing polynomials, remember how like 3x squared and 4, and we went like plus 4x squared would be 7x squared? Okay, well, you're right, because like these are like terms, right? X squared and x squared, so 3 and 4 would be 7, right? And then same thing if it was just x, right? If it was like 2x minus 1x, well, you'd go 2 minus 1, that would just be 1x, or in this case, just x, right? Okay, so same thing, right? We're just going to introduce that into solving equations now too, right? So let's do that on this example. 3x plus 2x, watch this. 3 plus 2 is 5, here, I'll write it again. 3x plus 2x is equal to 10. So if I collect these like terms, that would be 5x, right? 3 plus 2 is 5, is equal to 10. Whoa, is equal to 10. Okay, and then now what's left is I just want to get x on its own, right? So I'm going to divide both sides by 5. So divide by 5, divide by 5, so we get x is equal to 2. Now, you can always check it out to make sure that works, right? Let's try that. So I said x is equal to 2. So that should be the case that 3 times 2 plus 2 times 2 should be equal to 10. And let's see. So 3 times 2, well, that'd be 6. 2 times 2 is 4. Yeah, that is equal to 10, right? So I know for sure I got the right answer. That's kind of the nice thing about these, right? Is you can be like 100% sure that you got the question right on the test, right? Because you can just try it out, throw it back in, make sure it actually works. Okay, so let's do a couple. Actually, sorry, I'm not quite there yet. Um, so what I've done here, guys, I've given you just a bunch of examples to kind of just help you out, right? So these are in your notes. You can look back at these just to kind of help you when you're doing the questions. So in this case, I gave you a question where it was kind of a standard 3x minus x, but then you still had some stuff going on there. Yeah, so you go back and look and use these as a reference to kind of show how to do it. But you know what? I think what we probably could do is I'm actually gonna do some example questions on the back. But just remember that this is here, so you can use this as a reference, right? To kind of guide you how to solve these. And I know it looks confusing, but it's just one step at a time. It's all stuff you guys have already done, actually. It's just we're just doing a lot of it now, right? We're doing it all in one question. So okay, so let's do a few examples. So on this one. Know too that these will be the questions that you guys will be doing for homework, right? So it's in your best interest to pay attention. Okay, so this one is just like pretty similar to the one we actually just did right in the example there. So here, I'm just going to write it out over here. So 9x minus 7x is equal to 6. Okay, well, I'm going to collect those like terms, right? I need 1x. I want to combine these into just 1x I need to solve for. So 9 minus 7 is 2. And don't forget, it's 2x. And that's still equal to 6. Okay? And then you guys have done this in the last lesson, right? This is just... So right now I'm multiplying by x. So the opposite of that, I need to divide both sides by 2. So x is equal to 3. Okay. So now this one, we just introduced now one more thing, right? Because now you notice I have like another number over on the left side with the x's, right? So that's okay. Here, I'm going to write it again. So 6x plus 3x plus 1 is equal to 46. All right, so I'm going to do the same thing, though. Let's collect these like terms. Just turn those into the same thing, right? So 6x plus 3x, that would be 9x, right? 6 plus 3. And then I've still got plus 1 is equal to 46. Okay? And now this is a question you guys did in the last lesson, right? You've done these. So now what I'm left with here is I want to get x on its own, and I have a 9 to get rid of, and I have a 1 to get rid of. Like, I want to get them over there, I mean. Which one do I get rid of first? Well, the one on like the outside, right? We're gonna get rid of this 1, right? It's easy pickings here. I can get rid of this just by subtracting by 1, right? Because that would become 0. But whatever you do to one side, you got to do the other. So we'll go minus 1, minus 1. Next row down, I would say that we have 9x is equal to 45. Okay, so then very last step, just get rid of that 9 that we are multiplying by. So we're going to do the opposite, right? The inverse will divide by 9 on both sides. So x is equal to 5. Okay, let's move on to the next one. All right, so now, tricky little situation here. We'll walk through these steps. So negative 9x minus 8 is equal to negative 8x minus 3. All right, so in this situation, what I've got going on here is that, well, I can't really just collect my like terms. And the reason why I can't is because they're not on the same side of the equation, right? In order to collect like terms, they got to be on the same side. So either both on the left or both on the right, okay? So that's what we want to get in the end, right? So I either have to move this negative 9x over to this side, right? Now I'll show you how to do that in a second. Or I'm going to move this one over here to that side, right? They need to be on the same side. And here's how we move this term, right, over to this side. If I want to get this guy over to the other side, well, I need to get rid of it, right? I want to get rid of it on this on the left. So the way I'm going to get rid of that is I'm going to add 9x, right? I'm going to add the whole thing. Can you see that I've got negative 9x plus 9x? Well, what would that be equal to? Well, that'd be equal to 0, right? So it cancels. That whole term is gone. But that's okay, because whatever I do to one side, I have to do to the other. So I'm going to write it over here, and I'll say, okay, this is plus 9x, okay? And then we write our next step, right? So what do we have left? Well, now we have negative 8 is equal to, now, if you like, you can either just add these right now, right? You could say, okay, negative 8x plus 9x is just x, right? Negative 8 plus 9 is 1. So 1x or just x. You can either do that right now, or if you want to, you can actually write it out in a straight line like what we had before. So that'd be like negative 8x plus 9x minus 3, right? And the only reason I did that was because this is kind of the way that we've seen it, right? When we were collecting like terms, they were all kind of in a row like this. But either way, it's fine. If you want to skip that step and just call it 1x now, that's fine. But either way, what I'm going to do in the next one is I'm going to collect these like terms, okay? So far we have negative 8 is equal to, and then negative 8x plus 9x, right? Negative 8 plus 9 is 1. So 1x, or I'm just going to call it x. And then we still have this minus 3. Okay? Now just know I could have also, maybe I'm explaining a bit too much here. Like I said, I could have brought the 8x over there too, the negative 8x, done and added 8x. It all would have worked out the same. There's no one right way to do this, right? There's lots of different paths that you could take through solving these. But anyway, let's get rid of this negative 3. So now I'm going to say plus 3. Okay, so plus 3 on both sides, so those cancel. So we have x is equal to negative 8 plus 3, so negative 5. Notice that the x is on the right side. That doesn't matter. It doesn't matter at all which side you have x on in the end. Just do whatever kind of is the easiest, right? If x is already on the left, leave it on the left. If it's, it doesn't actually matter. So, okay. So that's a big concept. Make sure that you're kind of understanding how to take it from one side to the other there. But okay, let's move on. Okay, this one. Okay, so for this question, we could get out the calculator and you could actually just do everything like you normally would, but just start using decimals with your equations, right? But you know what I'm going to do instead is I'm going to make life a little bit easier on myself, and I'm going to actually change all of these decimals into integers. I'm going to change them into numbers that don't have a decimal in them, right? And it's actually easier than you think. If I want to get rid of all of these decimals in every term, well, can you see that this one, like this 3, is in the hundredths spot, right? And this one's in the 10th spot, 100th spot, and 10th spot, right? So what I need to do is I'm actually going to multiply every term, right? All 3 of them, or all 4 of them, by, it's always going to be like 10, 100, 1,000. It's going to be a base 10 number, right? And watch this. Like, what if I multiply every one of them by 100? So I'm going to multiply by, so actually that's a bad symbol. Let's go times, like dot 100. So times 100 times 100 times 100, right? So that seems like that's going to be confusing, and you might run to your calculator, be like, okay, well, what is 100 times 2.9? Well, that's easy with 100 because all you do is you move the decimal place over 2 times. Okay, and first off, maybe I'll talk about when you multiply everything by the same number, right? Like 100, 100, 100. It's actually okay. We didn't actually change the equation at all. Just notice it's still the same equation because we multiplied the left side, everything by 100, and we also multiplied the right side, everything by 100. So it didn't actually make a difference in the end. It all works out. So don't feel like we've changed the equation either. It's still the same equation. It's equivalent. It's in a different form. Okay. So anyway, let's go back to multiplying that by 100. So 2.9 times 100 is just 290. Do you see how there's 2 zeros in 100? So we just had to move it 1, 2 times. So the decimal is now like at the end. So 290x. Okay. And then the next one, I'm going to keep the minus. But now it's going to be, well, again, I'm going to move the decimal 1, 2 times. So that would be minus 105. Yeah, and there's no x, so just that. And that's equal to 120x. And then lastly, that would be minus, and then this would be 1, 2, so that it's after the 3 now, so that would just be minus 3. Okay? So now you might be thinking, well, that doesn't look any easier because now the numbers are bigger, but it actually will be better because if we end up with a fraction answer, it'll just end as a fraction. I'll show you what I mean. It'll work out better. So, okay. Let's get x on the same side again. Let's do the same thing we did last time, right? So what I'm going to do, I could either move this one over there, right? Or I could move this x term over there, right? Doesn't actually matter which one. I'm going to move the 20x to the other side. So I'm going to go minus 120x. So those cancel, right? And then minus 120x. Okay? So 290x minus 120x. So that's just going to be 170x, right? And if you want, like I said, you can just write it right now. So 170x. Okay, just subtracting that one and that one. And then I only have one x term now, so perfect. So then 170x minus 105 is equal to negative 3. Okay, so now we've done questions like this, right? This isn't too bad. So now what we're going to do, we're going to add 105. So plus 105 plus 105. So those cancel. So then the next step down, we have 170x is equal to negative 3 plus 105. Okay, and if you like, this would actually probably be a little bit easier to think as 105 minus 3, right? That'd be the same number. So that would just be 102. Okay, which makes sense. If you were at negative 3 and you went 105 to the right, you'd be at 102. All right, so now what we're going to do, we're going to divide by 170, divide by 170, okay? And then you just have x is equal to, and then it really is just 102 over 170, right? Like as a fraction, but we would like to simplify this thing if we can, right? You want to make sure that this is in simplest form. So when the numbers get bigger, it gets a little bit tougher, but it's really nice when they're both even numbers like this, right? Because I know what number goes into even numbers, right? 2 does. I can divide that by 2, and I can divide that by 2. So let's just do that. So we'll say x is equal to, so 102 divided by 2, so 51. Whoop. So 51 over, and then 170 divided by 2, 85. And now that they're not even numbers anymore, I can actually be pretty confident that that's as low as it can go. Yeah, and then that actually would be your answer, right? So notice why this was a better technique for us to multiply everything by 100 to begin with, right? Was because now we were able to just end up with an answer as a pretty complicated fraction, right? Or like a bigger fraction, right? Where if you would have left it as a decimal, your answer would have been a decimal. But like I said in class a few times, in math, we typically like to leave it as a fraction because that's a more accurate answer. And maybe for good measure here, let's say what that would be as a fraction. If you went 51 divided by 85, you get x is equal to 0.6. So, I just said this was a more accurate answer. 0.6 is accurate too because it just ends with a decimal. But, sometimes our fractions don't end like that. Sometimes our fraction would be like, 1 over 3 is equal to 0.33333, right? It's 0.3 repeated. So that's perfectly accurate. It includes all of the infinite number of 3's in it. But if I rounded it to 0.3, that's not as accurate, right? I had to round that. So anyway, that's why this is better. We like the fraction to leave it like that if we can. All right, moving on to the next one. All right, so on this one, again, I'll write it over here. 3 plus 2 is equal to 3 minus 3 x plus 7, and then plus 4x. All right, this is getting more complicated now, right? We got brackets in there. We got a lot going on. Good news is you guys did a lot of this kind of stuff in the last lesson of polynomials with, some of these more complicated expressions, right? So we're just going to have the solving part of it at the end, right? So let's just do it step by step here. First off, this 3 plus 2 on the left side, let's just call that 5, right? Because we can just add those. 3 plus 2 is 5. All right. And then moving on to the next one. Typically what you want to do when you're solving these expressions is we want to remove the brackets, right? I'd like when I collect my like terms, they all need to be in a line, right? They all need to be sitting there like 3x plus 2x minus 5, right? Like all my like terms need to be sitting there out in the open, right? I don't want these brackets. I don't know how to collect like terms when there's brackets sitting there. So we know how to deal with that though, right? The way we deal with this is we would take this number out front, right? This negative 3, okay? Because this is, even though it's minus 3, you can think of that as like negative 3. And it would be distributed, remember the distributive property, or rainbow, right? So we're going to multiply that guy in. Okay, so let's do that. So we'd have just this 3 sitting here. And then negative 3 times x is just negative 3x. That's all you can do, right? And then negative 3 times 7 would be negative 21. Okay, negative times a positive, right? Negative 21. And then we still have plus 4x. All right, Good to go. We know how to do this, right? So now on the next row, we'll say, okay, 5 is equal to, and maybe here, you know what we'll do? Let's collect any like terms we can right now in here, okay? Because I'm looking here saying, okay, I've got negative 3x and I've got positive 4x, right? I can just collect those, right? So let's call that, well, negative 3 plus 4. This is really just 1x or x, okay? And then I can even do the numbers right now too, right? I can just collect these like terms. So this would be 3 minus 21. So that would be negative 18. Okay, that looks a lot simpler. I know how to handle that now. So this would be, well, we'll just add 18 to both sides. So plus 18 and plus 18. So we get x is equal to 23. All right, now let's go through one of the ones that can be a little bit tougher. Okay, so yeah, we've got this one now where we just have 2 sets of brackets, but dun, 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 we've got a fraction, right? So I know a lot of times kids kind of freak out when they see a fraction, but it's not too bad. And actually, I'm going to show you a method where we can get rid of that fraction right off the bat. Okay, so here's what we're going to do. So again, I don't like the brackets, right? So we're gonna get rid of them, right? We're gonna use the distributive property to get rid of the brackets right out of the gates. So let's just focus on the left side here. So we've got 3 times 3x and then 3 times negative 2, right? So that would be negative 3, oh sorry, negative, what, negative? That'd be 9. That'd be 9x, and then 3 times negative 2, negative 6, okay? So that part wasn't too bad. And now over here, well, actually, you know what? Yeah, we'll do it this way. I'm going to show you 2 ways. So now we got 1/2, and we're going to multiply it by that one, and then multiply it by that one. And you guys are like, oh my God, I don't know how to do this. How do we multiply fractions? It's not that bad. Let's actually just focus on this one for a second. So if I've got 1/2 times 3x, right? Well, do you remember with multiplying fractions, how this is really like 3/1, right? And then multiplying is the easy one. Multiplying is just straight across. You don't have to find a common denominator or anything like that, right? So this is just 1 times 3x. That would be 3x. And then 2 times 1 is 2, so it's over 2. Do you see how you could almost kind of just like piece that together, right? Right off the bat, you're like, okay, the 3x is in the numerator. It's really up in the top, right? It's like 3/1. So it's like 1 times 3 is 3, and then the 2 is on the bottom, right? So you didn't even really have to write that out, right? Like that was pretty straightforward. Okay, so that would just be, yeah, so this is 3/2x. And then you've got 1/2 times negative 1. So again, this would be, let's just do it really quick. You don't have to do this after, but this would be like 1/2 times negative 1. And that you can think of that as negative 1/1, right? So that'd be like negative 1/2. It's so negative 1/2. So negative 1/2. Okay. So not too bad yet, but now we're gonna have to deal with this fraction, right? So the way we're gonna do this is we're gonna subtract negative 3/2x from both sides. So we'll say minus 3/2x and then minus 3/2x. Okay, and I'm writing in a room, so maybe I'll write it over here now. So I'm going to write this out again so we can deal with this. So what we have going on is we've got 9x minus 3/2x minus 6 is equal to, and then we just have negative 1/2 left over here. All right. Now, you know what? Let's get this negative 6 over there too, just so it's kind of ready. So we'll say plus 6 on both sides. So plus 6 and plus 6. And then I'm going to write it out all together again. So 9x minus 3/2x is equal to negative 1/2 plus 6. All right. So we're kind of there. Now what we got to do is we will collect like terms, right? But you might be seeing your issue. When we collect like terms, what I'm going to have to do is I need to go 9 minus 3 over 2. So I got to subtract a fraction, right? Well, what do you need when you subtract fractions? You need a common denominator, right? So I need to turn this 9 into something over 2, right? And a good way to think about this is really like 9 over 1 right now. So why don't we multiply the bottom by 2 and the top by 2, right? That would do it. So if we do that, our new expression would be 2 times 9 is 18x over 2 minus 3 over 2x. Okay? And you know what? I'm going to put equals, and then let's finish this part while we're thinking about it, okay? Because now we're almost there. Now we have like terms, right? These coefficients up front have like terms. Or sorry, not like terms, like denominators, right? They're the same thing. So now we can just subtract the numerators. 18 minus 3. This would be 15x over 2. And that's equal to, okay, so then let's finish the right side now. So same thing, what I'm going to want to do here is write this, over 2. So I'm going to multiply, well, this is over 1 to begin with. So I'll go, that was over 1. So then we're going to multiply the bottom by 2 and the top by 2. So writing that out again would be negative 1/2 plus 12 over 2. Okay, so now this would become negative 1 plus 12. So that would be 11 over 2. Phew. All right, I'm going to show you an easier way to do this after, by the way, too. Okay, so now I need x on its own, right? So what I'm going to do is I'm going to multiply both sides by 2. So I'm going to times 2, and I'm going to times 2. The good thing about this is since we had the 2 on the bottom on both, those cancel, but then actually so do these. Like I could multiply the top, make that 22, but why not just cancel those, right? So then I'm running out of room, but what we got left is x is equal to, or 15x is equal to 11. So then divide by 15, and then divide by 15, you get x is equal to 11 over 15, and that would be your final answer. All right, I know that was long and confusing with the fractions. There was a lot of skills in there. I wanted to show you that this was like worth doing, like you can see how to do it that way. But what I'm going to show you now is actually a simpler way to get rid of those fractions. We don't have any fractions right off the bat. Okay, you'll like this better, I think. But I think it was worth going through that so you can see that was also an option. Okay, what we're going to do now is I'm going to get rid of this issue, right? This 1 over 2. And the way I'm going to do it is I don't like this 2 in the denominator. So what I'm going to do is I'm going to multiply this by 2, right? So I'm just going to multiply it by 2. But whatever you do to one side, you got to do to the other. So I'm going to multiply this by 2. And don't worry that I'm not multiplying every term by 2, like everything. I kind of am, because when I multiply the front by 2, right, this is going to be multiplied by everything. So as long as you can understand that, like what's going on there, then you're going to be, then that's fine, right? But anyway, so now if we do this, if we just multiply this by 2, watch what happens. We've got 2 over 2, they cancel, and now that's just 1, so no fraction, right? Now I'm good. And then this would become 2 times 3 is 6, okay? And then this would still be 3x minus 2 in brackets is equal to, and now this is like 1 times 3x minus 1. But I didn't even really need that 1 anymore, did I? And to tell you the truth, I didn't even really need those brackets, because like 1 times 3x and 1 times, they would all be the same, wouldn't it? So yeah, in the next line, I'm just going to write it out the way it was. So anyway, so let's distribute that in. 6 times 3 is 18x. 6 times negative 2 is negative 12. And then you can distribute the 1 if you like, but really it doesn't matter. It's going to end up being 3x minus 1. Man, this looks way better than before, doesn't it? and we're going to get the same answer. So, okay, well, what I'm going to do, I'm going to bring the 3x to the left side there. So I'm going to subtract 3x and then subtract 3x. Okay, so we've got 18x minus 3x is 15x. Okay, minus 12 is equal to negative 1. And then I'm going to add 12. So we get, so anyway, yeah, we get 15x. Those cancel, so I get is equal to, this is going to be 11, right? Ooh, this is looking exactly the same. Okay, and then divide by 15 and divide by 15. So we get x is equal to 11 over 15. That was a lot nicer, wasn't it? So I would recommend doing this way, but as long as you understand what we did there, okay? Okay, and then quickly, I'll do this one. This one actually won't take too long, but when you run into it, I want to make sure you know how to handle this. So this would be 1 over 5 b plus 7 is equal to 7 over 4. Okay, so what I'm going to do on this one is actually, like, again, I could distribute this one out, but you know what? Man, that'd be hard. Like not too, like we could do it, but we just got a lot of common denominators to figure out and all that kind of stuff, right? It's going to be a lot nicer if we can do the same thing and just get rid of those denominators, right? Just get rid of those guys. So what I have to do in this one, though, and this gets a little bit more complicated, is I got to figure out what number does 5 and 4 both go into, right? And a good way to do that is usually, just you can multiply them, right? I can go, okay, 5 times 4 is 20, right? So, and you'll see why in a second, why that'll be nice. Okay, so actually, well, and the other thing yeah, let's stick with that. I'll explain it that way. So we'll say, okay, 20. Okay, so I'm going to multiply by 20. Do you see now if I multiply that by 20? Well, actually, we'll do the other one too, times 20. So if I multiply this side by 20, do you see how I have 20 divided by 5? That's going to give me 4, right? That's going to give me a nice number, not a fraction. So perfect, right? Same with this side. 20 divided by 4 is 5. Okay, again, that's going to be a nice number. So let's do that. So we'll go 20 divided by 5 is 4. So this will be 4 times, and then I've still got b plus 7, and that's equal to, and then here again, we'll go 20 divided by 4 is 5, right? So that's like 7 times 5. Hopefully you were following that logic, which is 35, and already that's 35 in the next step down. Okay, so all right, so we'll distribute this. So 4b plus, and then 4 times 7, so 28 is equal to 35. Okay, so we got 4b, oh, sorry, getting ahead of myself here, minus 28 from both sides, right? Getting rid of that 28, so minus 28, those cancel. So we get 4b is equal to, so 35 minus 28, it's going to be 7. And then last step here, we're going to just go, okay, divide by 4 and divide by 4. So we got b is equal to, and then just that, just leave it as 7 over 4. So I'll give you a heads up that if you had a hard time with maybe figuring out where this 20 came from, because we had to get rid of both of them, don't worry too much. That this is definitely more like an advanced question with that in Math 9. It wouldn't be like on the PAT where you had like, a number like that, but it could be actually, and it would be on the last question. This actually is an old PAT question. Yeah, so this one is free game, but you would only ever have to multiply by the 2, right? So you just know you had to multiply both sides by 2. This one was a bit more advanced where you had to figure out that you had to multiply by 20, right? Because 5 and 4 go into 20. Okay. Just know this too when you guys are doing your homework questions. I tried to make it so that every one of these questions has a video in it. Okay, so it kind of goes through questions like this. They might explain a little bit different, but that might be good, right? Different person explaining a little bit different. It's always a good thing. And then a lot of them also have like these written examples. So the numbers are different, I think, if you do the written example, but they'll kind of show you the same steps I just did if you have the same idea. What they did here, if this confuses you, um, instead of multiplying by like, when I went like 6 times 7, so I would have multiplied, both sides by, 42, right, on both sides. They actually just kept it as 6 times 7, right? That's what they did there. So, which might be even a nicer way to do it, right? So the 6's would cancel and you'd end up with just 7, right? And then on this one, the 7's would cancel and you'd end up with 6 times 8. But just notice that this is a tougher question, right? Like I totally get it, but yeah, that's the idea.